All right. Number 1. Do I need a common denominator?
No.
No. Why not? You're correct. There's not an addition or subtraction in between. When we're multiplying and dividing, we don't need a common denominator. When we're adding or subtracting, we do. All right, so when we're multiplying these two things together, multiplying fractions, you multiply just straight across. So in my mind, I just kind of drag this fraction bar over, and we know that we're going to be multiplying these things and multiplying these things. Before I go through and do any of the multiplication, is there anything that I can reduce to make my multiplication easier? What'd you say? 4 and 28. This would go to a 1, and this would go to a 7 because we have 4 times 1 and 4 times 7 here. So the 4's part would cancel out. I'd have the 1 and I'd have the 7 left over. Will anything else reduce as I try to make my multiplication easier? 14 and 16. 14 is 2 times 7. 16 is 2 times 8. So I see that my 2's will cancel out. I've got a 7 and an 8 left. So I'm just going to bring this over here and write down what I've got left over because I don't want to get too much going on the screen. If you do it all in one spot on your paper, cool. All right, so we still have the 7. That's getting multiplied to the x, and that's getting multiplied to the y to the negative 3. If it's times 1, do I have to write times 1? No. Because if I multiply something by 1, it just stays the same. So times x to the 3rd times y squared. All over, down on the bottom, I still had an 8. I have an x to the 4th still there. I have a 7. And I have an x to the negative 2. So there's 2 things that I'm looking at here. 1, I see something else that's going to cancel. The 7's. The other thing that I see is negative exponents. When I have a variable to a negative exponent, like y to the negative 3rd, how can I change it so that it's a positive exponent?
Switch them around the places.
Yep. Switch the sides of the fraction. So that one switches. Does anything else switch sides?
X negative squared.
Yep. X to the negative 2 is going to go to the other side. All right, so I have x times x to the 3rd times y squared times x squared. That x squared came up from the bottom. Over, I still have an 8 on the bottom. I now have a y to the 3rd on the bottom that switched places. And I have an x to the 4th. Will anything else reduce or cancel? These x's right here, this one is x to what power?
1.
X to the 1st power. So this together makes x to the 4th, right? Do I have an x to the 4th on the bottom? Yep. So that means that that cancels out. All right, so I still have y squared and x squared. I have 8 and y to the 3rd. Will anything else reduce or cancel? The y's. Are they going to totally cancel out?
No.
What's going to happen? There's still going to be a y in the denominator. Since the higher power is down on the bottom, I'm going to take the power on the top minus the power on the bottom. What's 3 minus 2? I'm sorry, what did you say? 3 minus 2 is not. If I hold up 3 fingers and I take away 2. Let me see where you're talking about. Where are you at? That moved to the bottom. Oh, you can do it like that, but then it would be a -1 on the top. I've got a +1 on the bottom. If you have a negative exponent on the top, what can you do with it? Move it down to the bottom. So what you have is exactly equivalent to what I have. Yours is just still up in your numerator. You need to move it down to the denominator before you can be all the way done with it. Not a 1, a y to the first power. But yes. All right. So what would my final answer be then? X squared over 8 times y. Absolutely correct. All right, let's look at number 2. Do I need a common denominator on number 2?
Yes.
Yes. Why?
There's a minus sign in between.
There's a minus sign in between. Anytime you have a plus or a minus, a common denominator is required.
But first you gotta factor.
Absolutely correct.
And you can use your shortcut.
That even works. Explain why.
A is 1.
All right, so we're going to factor that denominator. You said we can use our shortcut because a is 1. So I need 2 numbers that will multiply together to give me -28, but add together to give me -3. -7 and +4. So I have x minus 5 in the numerator over x minus 7, x plus 4, minus this other fraction. And now that I've factored that denominator, as I go after the common denominator, I know exactly what it is that my second fraction needs that it's missing. What does it need?
X plus 4.
An x plus 4. And so I just do it down here?
On both.
Both top and bottom. What we're doing here is kind of like unreducing the fraction. We need that common denominator, and so we're doing the reverse of reducing it. Do I have a common denominator now?
Yes.
Sweet. What is that common denominator?
X minus 7, x plus 4.
X minus 7, x plus 4. Up in the numerator, I have x minus 5, and then there's subtraction, and then x plus 4. What's my next step?
Multiplying negative x to x plus 4.
Yeah, we need to distribute, but remember, you're distributing a negative x here. So I'm going to bring my work up and around. That means up in the numerator, I have x minus 5 minus x squared minus 4x. Down on the bottom, I have x minus 7 and x plus 4. Do I have any like terms that I can combine?
X and negative 4x.
X and negative 4x. What happens when I put those together?
Negative 3x.
Negative 3x. So this one and this one. Does the negative x squared have a like term?
Nope.
So I'm going to bring that up to the front here. Yep, it is a negative x squared because we distributed a negative x. And then what do I have at the end?
Negative 5.
Negative 5. All over x minus 7, x plus 4.
Now you got factor again.
Now we do need to factor again. What's the first thing we always look for when we go to factor?
Common. The GCF.
GCF. Does that numerator have a GCF? -1. So let's take a -1 out. That means I'd have x squared plus 3x minus 5. As I try to factor this, will I be allowed to use my shortcut on it? Isn't it a plus 5? Yes, thank you. Because we took that negative out. You're absolutely correct. Will I be allowed to use my shortcut on that numerator as I try to factor it?
Yes.
Yes. Okay, so let's make our x. I need two numbers that multiply to give me a positive 5, but when I add them, I get a positive 3. What multiplies to give us 5? Anything else? Nope. Is there any way I can take 1 and 5 by adding or subtracting and get 3?
No.
So what would that mean about this numerator?
It's extraneous.
It's not extraneous, but does it factor?
No.
No. If it does not factor, then our fraction is fully reduced and we're done. And so I would call this my final answer. If you want to redistribute the -1, you can do that. I don't require it. If you leave that -1 out to the front, then I can see that you went after trying to factor it and found that it wouldn't factor. All right. We're going to be practicing the exact same skills today and Monday that we've been learning. We're not adding any new skills on. I want you to go to page 186. Page 186. All right, we got 3 problems on this page, 1 problem on the next page that we're going to look at. It says Patrick is constructing a model of a building. The length of the windows in the building can be modeled by, and then they give us an expression. So I'm going to circle that so I don't lose it, because anytime they give me an expression or an equation, it's probably important. And what did they say that represents? The length. What else do we know about these windows?
They also have the width.
They also have a width. What's the width?
12 over x squared
12 over x squared
minus 4.
minus 4. I want to write an expression for the perimeter of a window. How do you find perimeter of something? Yep, you add all the way around. So length, width, length, width. We do L plus W plus L plus W, which means I'm adding the length how many times? Twice. So it's 2 times the length plus what? 2 times the width. Because I've got the width written down twice and the length written down twice. And we're adding all the way around. All right, so I'm going to apply that to what we have here. The perimeter is equal to 2 multiplied by my length. What was the length? 24 over x minus 2. Plus 2 times the width. What was our width? 12 over x squared minus 4. And now I just need to simplify it using the skills that we've already learned. How do I multiply a whole number with a fraction? Calculator's not going to do 2 times x minus 2. I need to know how to use the calculator. What do I need to turn that whole number into? A fraction. I can turn any number into a fraction by doing what to it? putting it over 1. So I can put these guys over 1, and I know how to multiply two fractions together, right? How do you multiply two fractions? For multiplying? When do I need the same denominator? You just answered this earlier. When do I have to have the same denominator? When I'm adding or subtracting. Right now, I'm just multiplying these two things together. So do I need a common denominator there? Nope. How do I multiply fractions? Multiply straight across. If it can reduce, that's awesome. Reduce first if you can. So I'm going to multiply straight across the top. 2 times 24 would give me what? 48. On the bottom, what are the things that I'm multiplying together? 1 times x minus 2. What do I get when I multiply 1 times x minus 2?
X minus 2.
X minus 2. And that's going to be added to this fraction over here. What happens when I multiply these two fractions together?
24 is the numerator.
24 is my numerator. Over x squared minus 4. Now that I've taken care of multiplying both fractions by 2, I can work on adding those two fractions together. Now what is it that I need to have? Now I need that common denominator.
And you have a difference of 2 squares.
It is a difference of 2 squares. That makes factoring it much easier. So how's it going to factor then? So this factors to give me x plus 2x minus 2. That's how my difference of 2 squares will factor. So now I need to multiply the first fraction top and bottom by x plus 2. I need to shrink my work down a little bit. So that means I need to distribute this 48 to both of these pieces. I have my common denominator of x plus 2 times x minus 2. What do I get once I distribute the 48 to the x plus 2?
48x plus 96.
48x plus 96, and I'm adding that to what? 24. Do I have any like terms to combine? 96 and 24. What do you get when you add those two together? I'm sorry, one more time. 130. 48x plus 130. You said 120? Try it again. It is 120? Got it. Let's fix it. I just needed more consensus before I changed it. Am I done? What do I need to check for still? Factor the numerator. We're looking for a GCF. I don't see an x squared, so I know I can still look for a GCF. Is there anything that will go into 48 and 12 at the same time?
At the very least, 2.
At the very least, a 2. Is there anything bigger than 2? You said 12? So if I take a 12 out of both pieces, it's going to be 4x plus 10. Do 4 and 10 have anything in common? 2. So I can take out something bigger than 12 if I can still take out more. If I take a 2 out of each of these pieces, that means I would have to move that out to the front also. So I'd have a 12 out front and the 2 that I moved out front. Well, what is 12 times 2?
24.
24. So this actually has a greatest common factor of 24. You can pull it out a piece at a time just like we did. It's going to be over my common denominator. And that would leave me with, what, 2x plus 5? So my final expression for the perimeter morning, sir, would be 24, thank you, times 2x plus 5 over x plus 2, x minus 2. Can that actually reduce at all? Can I cancel anything now? Or is that fully simplified? Fully simplified. How do you know when you look at it whether it's fully simplified or not? We're looking that it can't factor anymore because I don't have any exponents. What do you not see? If I was able to cancel, what would you see? Sorry. What would you notice about the top and the bottom? There'd be something that's the same between the top and the bottom if I could cancel it. That's my fully simplified answer.
Because we divided by 4 and 2.
I divided, oh, no, I'm just saying I know that 2 can go into both of them. So that's what happens when we pull a GCF out. If I divide this by 2, I get 2x. If I divide this by 2, I get 5. But that 2 had to go somewhere. So I pulled that 2 out to the front. Does that make sense? Yeah. Because this one had a really big GCF, and sometimes we don't see the whole thing all at once. All right, let's look at the next one. The area of the door for a manufacturing company is represented by, oh, they gave me an expression. Circle it. And what does that expression represent again? The area. How do you find area of something like that's door shaped? Length times width. So area equals length times width. So looking at what they gave me to work with, I already know that there's a 4x squared plus 8x plus 13 equals something, because that's my area. What else did they give me? The width. The width is represented by what? 2x. I know this is length times width, so I'm going to put the 2x in here for width. Find the expression that represents the length. How do I get L by itself here? Divide both sides by 2x. Can I pull a 2x out of all the pieces on the top? No. Then I'm going to have to divide it a piece at a time. Do you guys remember how we broke it up into 3 separate fractions when I had a trinomial divided by a monomial? It's exactly what we're going to do here. So I'm going to write one fraction where 4x squared is my numerator. I'm going to write one fraction where 8x is my numerator. And I'm going to write a last fraction where 13 is my numerator. And I'm going to reduce each of these fractions, and that will be the expression for my length. Can I reduce 4x squared over 2x?
Yes.
Yep, what can go into both of them? 2x. So this is going to reduce down to a 2, and this will just cancel. Here I subtract the exponent by 1 because that was an x to the first power on the bottom. So this is going to reduce down to just 4x. What happens with this middle fraction? Can that reduce?
Yes.
To what? Just 4, right? The x's are going to cancel, and I have 8 divided by 2.
Hold on, I got a question.
Yep.
How did you get 4x?
What do you mean, how did I get 4x?
You could not be divided.
Yeah, it's supposed to be 2x.
2x, yes, thank you. We did divide. I wrote it down over here. Y'all are on it this morning more than me. And then I get to this very last fraction. Can that guy reduce at all? Nope. So then I leave it alone. Plus 13 over 2x equals my length. Since I've reduced all the parts, that's my expression for the length. Question, because yesterday was the first time I introduced this idea. Is this answer a polynomial?
No.
Why not?
There's an X
There's an x
in the denominator.
in the denominator. It's not that I'm not allowed to have x's at all. It's that they can't be down in the denominator. So, nope. X is still in the denominator. Number 3. What are they telling me about in number 3? 5x squared is what? The length. What else do they tell me? The width. That's 2x. What else did they give me?
The volume.
Volume. How do you find volume of something? What is volume? Length times width times height. Similar to area, it's the space on the inside, but when we're talking about volume, it's a three-dimensional object. So we would do length, width, and height, and the volume is all this space inside that I could fill it with. So if you think about it like a cereal box, the volume is how much cereal I have inside. All right, let's take what they gave us and substitute it into that formula. I have 70x to the 5th plus 40x to the 3rd minus 90x squared plus 100. That's the volume. What's that going to be equal to?
5x squared.
5x squared times what? Times 2x times h. 5x squared is our length. 2x is our width. So what do I do with it then? We will. I think we should probably simplify this first. Can I multiply these two things together? What's 5 times 2?
10.
10.
So you take it.
So it's, 10x cubed times h. That's just going to make my division here in a moment easier. Because I won't have to divide the 5x squared and then go back and divide everybody by 2x. I can do just one division problem now. We're going to divide everybody by 10x cubed. Does my numerator have a GCF?
Yes.
Yes, what is it? 10. I can take a 10 out of each piece. What would that leave me with? 7. You're just a little bit ahead of me. I'm just taking the 10 out. So 7x to the 5th plus 4x cubed minus 9x squared plus 10 all over 10x cubed. Why was it nice to get that GCF out to the front? Yep. And my 10s right here will cancel. So now as I break it up into smaller fractions, how many smaller fractions am I going to have? 4. 7x to the 5th over x to the 3rd plus 4x to the 3rd over x to the 3rd minus 9x squared over x to the 3rd plus 10 over x to the 3rd. Tell me how each one of these fractions is going to reduce or whether they don't reduce. Does the first one reduce? Yes. What am I going to get? 7x squared. We're going to minus the 3 from there. So I get 7x squared. Does the next fraction reduce? What happens? We just get 4. Does the next fraction reduce? Because top and bottom both have what? X's. So I'm going to take this exponent right here and I'm going to minus it. 2 is smaller, so I'm going to move it to the bottom. Yep, so I'd have 9 over x. And what about this very last fraction? Yep. 10 over x to the 3rd. That one does not reduce at all. That would be my final answer for the height.
And it also disqualifies it
From what?
being a polynomial.
There we go.
I was waiting for someone else.
Somebody else to fill it in. Not a polynomial because it still has x's in the denominator. Beautiful. Flip the page. We're probably only going to get through part A here. That's okay. We'll finish up on Monday with the last 2 pieces. We have a rectangle here. What do I know about this rectangle? What does it tell me about the rectangle? Starts off by telling me the area. And which rectangle is it telling me the area of first? A, B, C, D. Where is that rectangle? Top one. This guy right here is A, B, C, D. So I know the area, the space on the inside, is 2x squared plus 17x plus 35. What else do I know about this?
You're going to have to factor it.
Yep. Side AB has a length of x plus 5. So this side right here has this length. Is there anything else that I can fill in this picture? DEFG, they gave me the area. Well, down here is DEFG. So I'm going to go ahead and write the area in there. 4x squared minus 11x minus 20. Anything else?
So DF has length of 4x plus 5.
DF has a length of 4x plus 5. So that's this little thing right here. What do they want me to find first? AC. Beautiful. So if I have the area, I know area equals length times width. So 2x squared plus 17x plus 35 is equal to what? X plus 5. Or W or whatever. It's that missing side, right? So what do I need to do to get it by itself? Divide. We are going to finish up that division on Monday, and then we'll answer those last two questions. So we'll pick up here on Monday. You guys had a homework that was due this morning. If you have not done either of the homeworks yet in this unit, you need to. Pretty important here. Homework 3 will be due on Tuesday. Test is on Thursday. On Monday, I will give you a paper copy of the review so that you can begin working on that. Just like the last test, you are going to get a cheat sheet for this one. One side. Again, I'll give you a colored piece of paper. You'll write your name on the one side with all the printing, and then you get the other side to write down whatever you would like. We'll start working on that next week.